For over a century, physicists have been intrigued by the idea of black holes, with the concept gaining traction around 1916. These cosmic anomalies are among the most captivating and enigmatic phenomena we know, sitting at the intersection of vast gravitational forces and a peculiar invisibility to our understanding. A black hole, potentially weighing as much as 2 to 4 million times the mass of our Sun, remains a mysterious presence in the cosmos. Despite decades of intense research, our understanding has expanded from almost no knowledge to piecing together more details. With even more discoveries being made recently, a breakthrough by Michio Kaku has revealed startling insights about the interior of black holes, which may challenge our long-held assumptions and offer new perspectives on the nature of these celestial bodies. This new information opens doors to deeper explorations into what might have been overlooked until now. Join us as we venture further into the fascinating world of black holes and uncover what's hidden within the universe's vast and inspiring expanse. 1 minute and 3 seconds. What exactly are black holes? Before we delve into the latest findings by Kaku, it's essential to revisit the basic understanding of black holes. While most of us have at least a general sense of what a black hole is, there are still some key elements that remain unclear. In 1916, Albert Einstein's groundbreaking theory of general relativity predicted the existence of black holes. At that time, the notion was purely theoretical. It wasn't until about 50 years later that evidence was discovered, confirming that black holes are real objects in space. This revelation came in the 1960s during studies of the star X-1, a luminous celestial body emitting X-rays. Observations showed that these X-rays were not just randomly moving but were being drawn into a dense, invisible mass. This mass, later identified as a black hole, changed our perception of the cosmos. The discovery was monumental, as it proved that black holes were not figments of Einstein's imagination but tangible, elusive entities that warranted further investigation. Following this groundbreaking discovery, scientists worldwide began a global quest to uncover more about black holes. Their efforts led to the realization that the Milky Way alone may host around 100 million black holes. However, due to the challenges in detecting them, this estimate remains imprecise. Even though black holes are incredibly difficult to pinpoint, scientists believe that millions of these massive entities are hidden within our galaxy, making it even more crucial to understand them. 2 minutes and 39 seconds. Let's break down the core concept: gravity. Black holes exert such immense gravitational forces that anything entering their domain is squeezed into a singularity, a point where the laws of physics, as we know them, cease to function. In simpler terms, black holes are like gigantic vacuum cleaners, pulling everything into them. One of the most terrifying aspects of studying black holes is that if someone were to fall into one, they would gradually stretch out and become a singularity, their body torn apart by the intense gravitational forces before the point of total destruction. It's best to avoid getting too close to one, though they are scattered across the universe. Despite the nearest black hole being nearly 500 light-years away, the proximity still raises legitimate concerns. In 2021, scientists achieved a historic milestone by capturing the first clear image of a black hole, the M87 black hole. This achievement was the result of numerous nights spent taking photos and aligning them to create a single, cohesive image. As more data was gathered, researchers were able to discern that black holes consist of 3 distinct layers, contrary to the common misconception that they are just endless voids. 1. The event horizon marks the point beyond which nothing can escape. Once something crosses this boundary, it is inevitably drawn toward the black hole. 2. The photon sphere, the region where light itself gets trapped, unable to escape due to the powerful gravitational forces at play. 3. The singularity, the core, where all matter is compressed into an infinitely small point. Here, the very fabric of reality collapses, and all known laws of physics break down. What's even more intriguing is that each black hole is unique. While they follow the general 3-layer structure, their behavior can vary significantly, making them particularly challenging to study. Conventional scientific methods don't apply, so scientists must investigate black holes indirectly by observing the radiation they emit or analyzing the gas and dust swirling around them. Sending a probe directly into a black hole is futile. Anything that crosses the event horizon is inevitably pulled toward the singularity, where it is crushed into nothingness. This unavoidable fate means that billions of dollars cannot be spent on probes that would meet their end before offering any valuable data. Consequently, researchers must study black holes in 2 dimensions, despite them being three-dimensional singularities. 5 minutes and 46 seconds. Theories about the origins of black holes. Theories suggest that black holes may form when massive stars collapse in on themselves. As a star burns through its fuel, it can no longer produce enough energy to counterbalance the inward pull of gravity, leading to its eventual collapse into a black hole. If the star is massive enough, this process continues until the collapsing matter becomes a singularity. NASA scientists have turned their attention to the center of the universe, particularly the M87 galaxy, where they observed a powerful whirlpool of hydrogen gas spinning at mind-boggling speeds of 1.2 million miles per hour. The centrifugal force should have caused this gas to fly apart, but instead, it remained intact, suggesting the presence of a massive object at the center, likely a black hole. 6 minutes and 51 seconds. Theoretical advancements in black hole research. In 1963, New Zealand mathematician Roy Kerr used Einstein's equations to describe the behavior of rotating black holes. He argued that, rather than collapsing into a point as previously thought, a rotating black hole forms a thin, ring-like structure known as the ergosphere. This rotating disk of matter is key to understanding the breakdown of physical laws in the vicinity of black holes. Kerr's model also predicted the existence of an Einstein-Rosen bridge, a type of wormhole, which could serve as a shortcut through spacetime, connecting distant parts of the universe or even parallel universes. Physicist Michio Kaku further expanded on this concept, likening spacetime to a folded piece of paper. If you fold it, you create a shortcut between 2 points. This shortcut is the essence of a wormhole, a passage through spacetime that could connect distant locations almost instantly. While wormholes remain a theoretical concept with no direct evidence, they are a natural consequence of general relativity. However, they are inherently unstable and would collapse quickly if created. 10 minutes. The future of black hole research. One of the most exciting developments in black hole research is the growing interest in gravitational wave astronomy. This field emerged after the first detection of gravitational waves in 2015, a breakthrough discovery that confirmed one of Einstein's predictions from over a century ago. Gravitational waves are ripples in spacetime caused by the acceleration of massive objects, such as the collision and merger of black holes. Their detection has opened a new avenue for studying the most extreme cosmic events. In addition to gravitational waves, advancements in telescope technology, such as the Event Horizon Telescope, EHT, have significantly improved our ability to study black holes. The EHT was responsible for capturing the first-ever image of a black hole in 2019, offering visual evidence of their existence. Conclusion. The study of black holes continues to evolve rapidly, with new discoveries occurring regularly. As technology advances and new theories emerge, scientists are steadily piecing together the puzzle of these fascinating cosmic objects. Whether through gravitational wave detection, advancements in imaging techniques, or breakthroughs in theoretical physics, we are inching closer to unlocking some of the deepest mysteries of the universe. 15 minutes and 41 seconds. The next frontier. Black holes and quantum mechanics. As physicists push the boundaries of black hole research, one of the most profound challenges remains the reconciliation of general relativity with quantum mechanics. Einstein's equations describe black holes on a cosmic scale, but they do not account for the strange and unpredictable nature of quantum particles. The conflict arises in the singularity, where the fabric of space and time collapses. At this point, quantum effects should dominate, yet our current theories break down. This is why many scientists believe that uncovering the secrets of black holes may lead to the long-sought theory of everything, a unifying framework. That explains all forces of nature, from the largest galaxies to the tiniest subatomic particles. One promising avenue in this quest is loop quantum gravity, LQG. This theory suggests that spacetime itself is quantized, composed of tiny, discrete loops rather than being a continuous fabric. If true, it could provide new insights into what happens at the core of a black hole and whether singularities truly exist or if they are instead replaced by a new, unknown structure. M. Yakubu's latest research suggests that black holes may not be the final stage of a collapsing star but could lead to new exotic states of matter. Some theories propose that, rather than forming a singularity, the extreme gravitational pressure inside a black hole might create Planck stars, objects where quantum effects prevent complete collapse, offering a potential escape from the black hole paradox. 17 minutes and 20 seconds. Are black holes gateways to other universes? One of the most tantalizing possibilities is that black holes might not just be destructive voids but could serve as gateways to other universes. Theoretical physicist Nikodem Poplawski has suggested that matter falling into a black hole might not be destroyed but instead transported into another universe through a white hole, a hypothetical counterpart where matter is expelled rather than consumed. This radical idea challenges our understanding of the multiverse, the theory that our universe is just one of many. If true, black holes might act as cosmic bridges, allowing energy and information to flow between different realities. Recent studies involving quantum entanglement also hint at a possible connection between black holes and wormholes. The concept, known as ER equals EPR, suggests that pairs of entangled particles are fundamentally linked in the same way that wormholes connect distant points in spacetime. If this idea holds, it could revolutionize the way we think about black holes and their role in the cosmos. 19 minutes and 2 seconds, the search for microscopic black holes. While supermassive and stellar mass black holes dominate the universe, some physicists believe tiny, primordial black holes might also exist. These hypothetical black holes could have formed shortly after the Big Bang, and they may hold the key to understanding dark matter, the invisible substance that makes up most of the universe's mass. Experiments at the Large Hadron Collider, LHC, have searched for evidence of microscopic black holes, as their formation would suggest that extra dimensions exist beyond our familiar three-dimensional space. Although no definitive proof has been found yet, the possibility remains open. If scientists were to detect a microscopic black hole, it would confirm some of the boldest predictions in modern physics, potentially revealing new laws of nature and exposing hidden dimensions that shape our reality. 21 minutes and 15 seconds, the fate of black holes and the end of time. Even the most massive black holes are not eternal. Thanks to Hawking radiation, black holes slowly lose mass over time. However, this process is incredibly slow. Supermassive black holes could take trillions of years to fully evaporate. But what happens when the last black holes finally vanish? Some cosmologists believe this could mark the ultimate fate of the universe. If dark energy continues accelerating the expansion of the cosmos, galaxies will drift apart, stars will burn out, and black holes will eventually evaporate. This could lead to a cold, empty universe, a heat death, where no new stars or planets form, and all that remains are weak traces of radiation. However, other theories propose a more dramatic ending. Some suggest that quantum fluctuations in empty space could trigger a big bounce, resetting the universe in an endless cycle of death and rebirth. Others believe that, just as black holes consume matter, they could also play a role in shaping new universes, possibly giving birth to entirely new cosmic realms beyond our own. 23 minutes and 10 seconds, the future of exploration. As technology advances, new missions aim to bring us closer to the mysteries of black holes. NASA's upcoming LISA, Laser Interferometer Space Antenna, project will detect gravitational waves with unprecedented precision, allowing scientists to observe black holes merging across the cosmos. Meanwhile, new generations of telescopes, such as the James Webb Space Telescope and future quantum observatories, promise to provide sharper images and deeper insights into these cosmic giants. But perhaps the most ambitious idea is the possibility of sending nanoprobes toward black holes. Using light sails powered by lasers, these tiny spacecraft could travel at a significant fraction of the speed of light, potentially gathering data from the outskirts of a black hole without falling in. While direct exploration remains a distant dream, the next century may bring technological breakthroughs that allow us to finally unlock the deepest secrets of these enigmatic objects. Black holes have long been symbols of the unknown, but with every discovery, we come closer to understanding their role in the universe. From their mysterious interiors to their potential as cosmic gateways, they remain one of the most awe-inspiring frontiers of science. As we continue our journey into the cosmos, one thing is certain: black holes are not just the end of the story, they may be the beginning of something even greater. Black holes and the future of space travel. As our understanding of black holes